quick overview of rubber dumbbell testing, ISO 37 and also ASTM D412. Got some information on our website. For this test I'll be using a Test DVU 2.5 and I'll be using a 500 Newton load cell, although you could use a smaller one for lower force applications, together with a long travel extensometer, the MLT 700, some eccentric self-tightening roller grips rated to 1K, and Vector Pro MT software. So we'll have a look at our Vector Pro setup. Just log on to it. So I've set up two tests, D412 and ISO 37. They're very similar, slight changes in the setup. So attributes, I've named my test, I've got some test notes in there. I've specified the dumbbell type that I'll be using, type C, and I've put in the test temperature. You can obviously add more attributes to identify the sample ID and things like that. Named it as dumbbell type C, and I've given my dimensions of width and thickness, 6mm by 4mm, and a 50mm gauge length. It's worked out my area. Set my brake detector up to a 50% drop. And then we've got our extensometer, so we need to enable it and turn the analog on. And I'll do the prompt per specimen so we can remeasure it before we do each sample. Simple test, zeroing out. We're travelling at a rate of 500mm a minute, returning home. And then we've got some results in here. I'll put the timestamp and the specimen details. Some of the attributes are in here. And then I've got some calculations. So I've got the tensile strength, which is on our stress strain axis. So our maximum, and then we'll be looking at a break and strength of break, so it's stress strain, a drop of 1%. We'll look at Young's modulus, we turn it on so we use by other results on the stress strain axis. This is for our offset yield, so we're looking for a 1% yield on this to find the offset yield point. And then we'll look at some stresses at specific strain values. You can see there's one here on 50%. So we set the X to 50% and occurrence 1. Then we can repeat this process for different levels of strain. So I can pick it out at 100%, and I've got 200% and 300%. There are variables within the standards on testing speeds and things like that, and specific results, but the core is there and you can modify this accordingly to your requirements. So that's the ASTM D412, and I'll save my changes. And we'll look at the ISO 37. Again, I've added the same attributes in here, specimen type, temperature, I've got a picture in there. Look at the specimen this time, dumbbell type 1, width and thickness, but this time a 25mm gauge length. Got our area, set up our brake detector for a 50% drop, and enable our extensometer, and prompt for specimen is also on. The operations again, very similar. As I say, you can change your speed according to the standard. It does specify several different testing speeds. We'll look at our results. So we've got our tensile strength again on the stress strain axis. Break, our strength of break on the stress strain with a 1% drop. Stress versus time. We've got a second break. This time we're looking at the elongation of break, so we do it on the strain axis, same 1% drop. And we repeat our process with our stresses at particular levels of strain. We just set it on the x-axis. So we've got 100, a 200% strain. Stress at an elongation, so we're looking at a particular stress at a particular elongation of 50%. You can modify that. We're looking at elongation at X stress, so we're actually looking at a stress this time and reporting what the strain is. So this time it's on the y-axis. Young's modulus again, used by other results. And then we've also got our offset yield twice, so we've got our yield stress, so we're looking for a 1% yield stress, and then also we want to know what the elongation is, so this time we've got the axis set to the strain and at 1%, so we'll report the elongation they yield. And that's the tests quickly set up. You can also modify them slightly if you wish. We're using these eccentric roller grips. I'm just going to load the sample in. So there's my dumbbell. Load it in the top grip, load it in the bottom grip. Make sure it's nice and level and straight. And then we've got our extensometer. So we're going to do the ISO test. So I'm set at a 50mm gauge length, so I'll remove the gauge pin and set it at 25mm. This will set the arm distance, 25mm. And I can connect the arms up onto the sample. And we can see this from the front as well, so you can see what exactly how this works. So we're just spreading the arms, moving them in, keeping the gauge length set with the pin and the arms together, and then we're set. Now we can start doing a test. You can see the sample elongating and the arms tracking the gauge length as it moves up. And we're going to pull this until it breaks. There we go, sample's broken. Go back in and do a test, and we'll look at the graph this time. So we're set to stress strain, press play. So there's our test temperature required, 21.1, ambient temperature, and now we can modify our width and thickness of our particular sample so we get accurate stress calculations based on the sample dimensions and the area. And carry on, and we're off and running with the graph. I used a 500 Newton load cell on this, and forces are a lot lower. You could get away with a 100 Newton load cell. And test continues until it breaks. I think it'll be just past the 300% mark for this particular sample. There we go, the sample's broken. And the machine is returning back to its home position. Now let's go and have a look at that graph. There's our graph that we produced, and now look at our results. So we've got our tensile strength. We have our strength at break. It's marked it slightly just below our 1% drop. Our elongation at break. And then we've got our strains at 100%, at 200, and at 300. And our other results we've got in here. We've got our stress at an elongation. I think it was 50% we asked for on that one. Our Young's modulus line's been marked. Our yield stress, 0.24 megapascals, and our elongation at that point as well. I've got another calculation here, the force at 100% stress. And here's a video of another test I did where you've got an in-screen video. You can actually see both things happening at the same time. And that concludes the presentation.